Okay, Mr. Baumer here, and welcome to the second half of Chapter 9. All right, we're going to be learning in this part of the chapter, all right, in this unit of study, 4 different ways to solve quadratic equations. All right, 4 different ways to solve quadratic equations. All right, 2 of which we'll talk about today. All right, so while you're writing down the objective here on the bottom of the screen, all right, student will be able to solve quadratic equations by factoring. All right, so the technique we're clearly going to focus on today is factoring. All right, that was chapter 8 to us. We spent an entire chapter, we spent an entire 6 weeks almost learning how to factor. All right, so hopefully those skills are still relatively fresh in you. I'm sure some of you will need to be reminded a little bit. Oh, that's right, that's what we do. All right, but we're going to be using factoring. So if your factoring skills aren't up to snuff, so to speak, you probably need to see me and get some extra work on that or get some extra help with that. So, first thing, put your pencils down, all right, because you're not starting to take notes right away. You need to understand, I'm going to lay the groundwork, lay the foundation of what we're doing, all right? So what we have already done is this. That's what we just spent the first half of chapter 9 doing. How do you graph quadratics? Now, if I were going to graph this, I happen to know, right? I mean, you could go through the process of graphing this. Well, the most important point to find is the vertex, all right? So the opposite of 4 divided by 2 times 1. That's 4 divided by 2. So the x value at the vertex is going to be on this line right here, but where is it? Well, when I plug 2 in, I get 2 squared is 4. 4 minus 4 times 2 is 8. 4 minus 8 is negative 4. So the vertex is at 2, negative 4. Right here. All right. Now I happen to know that some other points that are going to make this true are these points right here. All right. So I could graph that. All right. Like that. All right. Of course, this right here would be known as our axis of symmetry, all right? But these things here are known as our what? And those, of course, hopefully the word came to mind that those are our zeros, all right? Now what we're going to do is now what we're going to be working on is this. Well, what's the difference between this one and this one, all right? One of the things you probably notice right away is that, wait a minute, this one has 2 variables. It has y's and x's, where this one only has x's. And we're going to be asked to, the instructions here are going to be to solve quadratic equations. Now, what does it mean to solve something? It means come up with the values of x that make this true. We come up with the values of x that make that true. Well, how in the world are we going to do that? Well, these numbers right here actually produce a 0 value. All right, look at it. This number right here, which is x is 0, and this one right here, x equals 4, those will actually make this true. Let me show it to you. 0 squared is 0, minus 0 is 0. Hey, makes it true. 4 squared is 16, minus 4 times 4 is 16. 16 minus 16 is 0. So both of these make it true. So one of the ways to solve quadratic equations is to make them into quadratic functions and then graph them and look for the zeros. All right. Now, what we're going to be learning, we already spent a chapter, or half a chapter really, a unit of study for us, graphing. All right, and we will come back to that a little bit, but I want to start with solving by factoring. So, what's the first type of factoring we always start with? Greatest common factoring. So if I'm just looking at this, the first thing I'm going to do is set my equation equal to 0. How do I factor this? What can I pull out of those two? Well, I can pull an x out. And if I pull an x out, I'm left with x minus 4. X times x minus 4. Now, here's the thing you need to focus on today. How can we solve these by factoring? Well, it's all based on this thing called the zero product rule. All right, and you need to really understand the importance of this. It's a very powerful tool in math. And it comes from this. If I tell you that a number times a number equals 0, what do you know? Well, you know that one of these parts has to be 0. Either this one is 0 or this one is 0. They don't both have to be 0, but we know without a doubt that one of them has to be 0. That's called the zero product rule. Now, here we don't have a multiplication problem. Here we do. If you remember, I stressed during the factoring unit what is factoring, and to us it's creating a multiplication problem. So, if we can create a multiplication problem, we know something. Now look at this. This one is 0 equals x times x minus 4. So I know that either this is 0 or this is 0. And that allows us, what we're going to work on here in a minute when I ask you to pick up your pencils and start taking some notes, these are things I call mini equations. Either x equals 0 or x minus 4 equals 0. Then we just have to solve those. Well, this one's already solved. This one, if I get x alone, x equals 4. Wait a minute. The solutions we got by factoring were the zeros we would get by graphing. All right, pick up your pencils. Here we go. Let's start looking at some problems here. Let me make it a little bigger. So, right here, solve this. Now, at the bottom, you'll notice down here, we have some steps. First step is set the equation equal to 0. So, how am I going to get this over to the other side? Well, I'm going to add it to both sides. So if I'm rewriting this equation, I'm going to get x squared plus 7x plus 10 equals 0. So we've accomplished step 1. We've set it equal to 0. Now, remember, we're going to use this thing called the zero product rule, which means we need to make this into a multiplication problem. How do we do that? Well, that means to factor it. Now, let's think about the ways we factor. There was greatest common factoring. Is there a greatest common factor to this? No. Then, of course, you remember that flow chart, that kind of algorithm of how we think about this. How many terms are there? There are 3 terms. What type of factoring were we doing to 3 terms? And that's right, it was the x factor. So, if we're setting up the x factor to this one, what goes here? Remember, it was a times c. So a times c, so that's 10. It adds up to 7. What are the numbers that multiply to 10 that add up to 7? They were 5 and 2. Remember, we used those to break this into 2 terms. All right, so now we have x squared plus, now we have 5x and 2x, and we still have our plus 10, and we still have equal to 0. A lot of people, for some reason, when we start doing this, their equal to disappears. All right, remember, math needs to be true from line to line. Now, how did we factor these 4 terms? Well, we factored by grouping, which meant we were going to look at these 2 terms, and separately we were going to look at these 2 terms. All right, well, what can I pull out of these 2? I can pull an x out of those 2, times x plus 5, which you'll remember we immediately rewrote, and then asked ourselves what goes here. Well, that's a positive 2. Remember, it's still equal to 0. Now, how do we go from there? Well, it was x plus 2 times x plus 5 equals 0. Now, let's check and see where we are on our flowchart. Factor the quadratic expression. We've done that. Write your mini equations. What the heck is Mr. Baumer talking about mini equations? All right. Well, based on the zero product rule, let's look at this because it's very important you understand this, how powerful this zero product rule is. This says that something, yes, it's a chunk of something, it's a quantity of something, but it says this times this equals 0. So we know that either this one right here equals 0, or this one right here equals 0. So we have mini equations that happen to be linear mini equations, all right? Meaning they're degree 1, meaning, hey, we should be pretty good at this point of the year in solving those. So how do I solve this? I move the 2. X equals negative 2. Or x equals negative 5. Those are our 2 solutions. Now, how many solutions will we have? Well, that comes back to how many zeros would the graph of a quadratic have. It could have 2, it could have 1, or it could have 0. So in this case, we got 2 solutions. All right, let's look at another problem. Here, again, first step needs to be set the equation equal to 0. So I need to move this 5x to the other side. So when I do that, I get x squared minus 5x, remember when you change sides, you change signs, equals 0. Now, Second, factor the quadratic expression. Well, what type of factoring do we always start with? Greatest common factoring. So what can I pull out of both of these terms? I can pull out an x. Times what? Well, x minus 5. Now, we have created a multiplication problem that is equal to 0. So again, coming back to this zero product rule, all right? We either know that this is 0, or we know that this is 0. And that allows us to write our mini equations. So I know that either x equals 0, or I know that x minus 5 equals 0. So how do I solve those? Well, this one's already solved. So x might be 0. This one, how would I solve that? Well, I'd move the 5 to the other side. I'd get x alone. So x equals 5. So we have two solutions, 5 and 0. Now, let me try and tie some of this together. What if I graphed this? Right, x squared, same as this, minus 5x equals y. Where would the zeros be? That's right. They would be at 5 and they would be at 0. All right. So again, graphing is another way to solve this. All right. I want to connect these two ideas because we just spent a unit graphing. Let's look at this third problem. What's the first thing I should do? That's right. I should set it equal to 0. All right. So I got a choice. Either I can move these to this side, or I can move this one to this side. All right, and I would always like my x squared term to be positive. It doesn't have to be. That's just a preference of mine. I'd always like my x squared term to be positive if I can. So I'm going to choose to move the negative 2x squared to the other side. Now that's going to produce the equation 0 equals 2x squared minus 2x. Why am I writing it that way? Well, remember, I'm writing it in standard form, plus 18. So we've set it equal to 0. Now we need to factor the quadratic expression, which means we need to factor this. Well, is there a greatest common factor? Yeah, actually there is. All right, some of you would have gone right away to x factor because there's 3 terms. Well, there are 3 terms, but there's also a greatest common factor. I can pull a 2 out. X squared minus x plus 9. Now, 2 can't be factored any further, but this one might be able to. So if we're setting up the x factor here, remember that expression factoring completely, what are the factors of 9 that add up to negative 1? What are the factors of 9 that add up to negative 1? Now, are there any? Well, we better think about that. And I want you to think about that and be prepared to talk about it when you come into class. Okay? So we're going to finish this one. But I want to start in class. We're going to finish this one. But I want to talk about this. Here's the takeaways you should be taking away from our little video today. All right? This is what you need to walk away like understanding. Quadratics can be solved by, one method is graphing. Remember, the zeros are your answers. So if we graphed something and it had 2 zeros, those would be the solutions to the related equation, meaning replacing y with 0. We can also solve by factoring, which means we need to set it equal to 0. We need to factor the expression, and then based on the zero product rule, we should be able to find our answer. If something times something equals 0, we know that either this thing is 0 or this thing is 0. And those are what I call our mini equations. All right, so those are the takeaways. Understand that, you'll have a good chance to start being successful in this next unit where we're going to learn a lot of different ways to solve quadratics. So, hope that made a little bit of sense. Again, we're not asking you to master anything by watching this video. We're asking you to have a foundation that when you come into class, we can immediately start working on solving problems by factoring. So, we'll see you next class.